Hello, and welcome to the second lesson on trigonometry. Today you are going to learn about what are called the sine and the cosine and the tangent of an angle. And the way that we find these is by labelling the sides of a right angled triangle in the same way that you learnt last time. So remember, the hypotenuse is the longest side, the opposite is the one which is opposite the acute angle, which is marked. So over here is the opposite, and the third side is called the adjacent. And the definition of the sine of an angle, and we often shorten that to sin, and you might have seen that on your calculator, the sine of an angle is always the length of the opposite side divided by the hypotenuse. So if we look at the example below, here's angle theta. So labelling the sides, there's the hypotenuse, the longest side. This one's the opposite angle theta, and 4 centimeters is here. That's the adjacent. To find the sine of the angle, we do the opposite divided by the hypotenuse. So here, that's just 3 divided by 5. And sorry, I forgot to say, this symbol theta, it's actually a Greek letter of the alphabet, and we often use it for an unknown angle, so an angle we don't know the size of. Okay, let's go on and find out about the cosine of an angle, which we often shorten to cos. Okay, the cosine of an angle in a right angled triangle is always the adjacent divided by the hypotenuse. So if we look at the triangle below, again, here's the hypotenuse, this one's the opposite, this one's the adjacent. To do the cosine, we do the adjacent divided by the hypotenuse. Well, that is 4 divided by 5 as a fraction. Okay, there's a third one that we need to know about, and that's called the tangent of an angle, which we often shorten to tan. So the tangent of an angle is always the opposite divided by the adjacent. So again, using the same triangle, there's the hypotenuse, that's the opposite, that's the adjacent. The tan of the angle, so here's angle theta, the tangent of theta is the opposite divided by the adjacent, so that is 3 divided by 4, or as a fraction, it's 3/4. On this slide, I'm showing you all three on the same page. So the sine of an angle is the opposite divided by the hypotenuse. Now, to remember that, if you look at the first 3 letters of sine, opposite, and hypotenuse, that's SOH. The first 3 letters of cos, which is equal to adjacent over hypotenuse, is CAH, and the tan, remember, is the opposite over the adjacent, and that gives us the letters TOA. And if we remember these 3 strange words, so, ka, toa, and most importantly, how those words are spelt, then that will remind us how to find the sine and the cosine and the tangent of an angle. So let's see how that works. Oh, before that, you need to learn SOHCAHTOA. You could just learn the word SOHCAHTOA, or the 3 words if you like, SOHCAHTOA. If you find that difficult, you could maybe make up a little mnemonic. So here's one: silly old Harry caught a herring trawling off America, gives you SOHCAHTOA with the first letter of each word. Or the old Arab sat on his camel and hummed would be another way of remembering them. Not such a good order. We normally remember SOHCAHTOA, so the first one is probably most useful. Either way, you have got to learn those. You're not given them in an exam, you need to know them. So how do they work? Well, first of all, let's do a fairly straightforward example. Let's just move that out of the way. So I've put those there to remind us. So for this particular triangle, we're going to find the sine and the cosine and the tangent. Okay, so first of all, label the sides. So there's the right angle. So here is the hypotenuse. Angle theta is down here, so the 12 centimeters is the opposite, and the 5 centimeters then must be the adjacent. So first of all, to find sine theta, well, that's going to be the opposite divided by the hypotenuse, and the opposite divided by the hypotenuse is 12 over 13. Okay, cos theta, well, that's the adjacent divided by the hypotenuse. So if we look at the labeling, that's 5 divided by 13, or 5/13. And tan theta, well, that's opposite over adjacent. Opposite divided by adjacent, well, that's 12 divided by 5. Okay, so sometimes you might just need to find them as fractions. So just leave them as fractions. Okay, the next one is very similar. So I'm going to explain how to do it, and then I'm going to ask you to pause the video and have a go at doing these three by yourselves. Okay, so in this case, a little bit more complicated, because as well as just finding them as a fraction, I would like you to work out each one to 3 decimal places. Okay, so first of all as a fraction, so something over something, and then to 3 decimal places. So pause the video now and have a go at doing that. Okay, welcome back. Hopefully you'll have the same as me. So the sine, that's the opposite divided by the hypotenuse. Well, let's label first. There's the hypotenuse opposite the right angle. This is the opposite angle theta, which means that this one must be the adjacent. So sine theta, opposite over hypotenuse, well, that's 5.4 divided by 9.1. On a calculator, that's 0.5934, and so on. So round it to 3 decimal places, 0.593. Next one is the adjacent divided by the hypotenuse. Well, that's 5.4 sorry, hang on a minute. Oh, I've just moved it. Oh, sorry, I was just sorting that out on my calculator. Cosine is adjacent divided by hypotenuse. Well, that's 7.3 divided by 9.1, and that comes out as 0.8021. So to 3 decimal places, 0.802. And the last one, tan theta, well, that's going to be the opposite divided by the adjacent. So that's 5.4 divided by 7.3. And that comes out as 0.7397. And if you round that to 3 decimal places, it's 0.740. Okay, last example. A little bit more complicated now, because what I've done is I've labelled the 3 corners, which you could also say are the 3 angles of the triangle. So remember, the way that we label the sides is that this side over here is BC, this one over here is AB, and the hypotenuse is AC. That's how we name them. So for this one, we're not going to find any numbers, and we're not going to find any values. We're just going to find in terms of letters. So cos A, well, that means this angle here. Well, for this angle here, remember, this one is the hypotenuse, longest side. The hypotenuse never moves, by the way. The opposite is this one, and the adjacent then is over here. So to find the cosine, well, that's the adjacent divided by the hypotenuse. That's just going to be AB divided by AC. Okay, next one, tan C. Well, angle C is this one over here, which means that the opposite and the adjacent are actually going to swap places. The opposite now becomes this one, and the adjacent then must be BC. So tan C is going to be the opposite divided by the adjacent. Well, that is AB divided by BC. Last one, sine A. Well, we're going back to angle A now. So for angle A, remember, the hypotenuse doesn't move. The other two swap over sometimes. So for angle A, which is this one up here, the opposite is BC and the adjacent is AB. And we're being asked to find the sine of A. Well, the sine of A is the opposite divided by the hypotenuse. So that's BC divided by AC.